isomerism. So what is the difference in chain isomerism and ring chain isomerism? A compound will form a cyclic compound as well as a linear compound. Suppose for example I am taking an alkene. The alkene will have one unsaturated bond. The degree of unsaturation in alkene is 1. In the same manner, if I am taking a cycloalkane, that will also have the unsaturation 1. That means degree of unsaturation is 1. Okay, we will see with an example. If suppose I am taking cyclopropane. Cyclopropane, this contains 3 carbon atoms with hydrogens. And in the same manner, a linear compound, I am taking this is 1 propene. 1 propene and cyclopropane. These two are called to be ring chain isomers. The molecular formula, if I am checking, it will contain 3 carbon atoms and 6 hydrogen atoms. So the molecular formula of both the compounds are same, but this is a linear compound and this is a cyclic compound. A linear compound, a linear alkene, when changes to a cycloalkane, this is considered to be a ring chain isomer. One of the pi bond is delocalized and here we are getting the ring chain isomerism. The ring chain isomer is not only a chain isomer, but it also satisfying the constraints for a functional isomer also. Just check, we are having alkenes, dienes. This is alkene-diene. Butadiene. And this is but-1-ine. This alkyne and this alkyl-diene. Alkyne and alkyl-diene. These two are functional isomers actually. This is an alkyne and this is a diene, carbon diene. So this both are functional isomer, but both this functional isomer will have a cyclic butane and this is a cyclic compound. So we are having cyclo-but-1-ene. These compounds are isomers to each other, and this is chain length isomer or ring chain isomer. We will call it as ring chain isomer, and this is also ring chain isomerism. And in between these two, we are having functional isomerism. Functional isomerism in the sense the change in the functional group will be